Okay, great. So let's get started. Welcome to everybody. This is our first webinar in a series for the California Psychedelic Bar Association. I should note that it's being recorded and will be posted on YouTube afterwards. So don't do anything on camera that you wouldn't want to do on YouTube. I'm Paul Slattery. I'm one of the two co-founders of the Bar Association. When I'm not doing this, I'm the general counsel of Eleusis, which is a psychedelic pharmaceutical company. My co-founder, Rebecca Lee, is with us. She is the general counsel of Journey CoLab, as well as pretty much the brains of this operation. As these webinars progress, they'll tend more strictly toward law and legal issues and lawyers talking to lawyers. But before turning to the law and regulation of psychedelics, we thought it would be useful to start with a background knowledge of psychedelics, because not everybody's sort of on the same page there. We're very lucky today to have Professor David Nichols speaking with us. I should note that he and I work together at Eleusis, so we know each other pretty well, so I'll probably call him things like David and not mean any disrespect from that. So hello, Professor Nichols. How are you?
Good. It's afternoon. Happy afternoon.
Great. So putting together any kind of brief summary of your career and all of the things you've done is very, very difficult, and I thought it would be boring to listen to me talk about it. So I thought it'd be more interesting to have you sort of tell the story as you see it. So could you take a few minutes and just give us sort of background on your career from grad school through now?
So from soup to nuts, huh?
Just the highlights if you like.
Yeah. Let me see if I can compress it a little bit. I started graduate school in 1969, and I studied what were then called psychotomimetics. Basically hallucinogens, now called psychedelics. In 1970, the Controlled Substance Act got passed. So I thought, well, I'm going to enjoy my graduate career, and then that'll be the end of it, because there's no future in this field at all. As it happened, I got a position as an assistant professor of medicinal chemistry at Purdue University in the fall of 1974, after I'd done a postdoc in pharmacology at Iowa. And that allowed me to do pretty much what I wanted. And then I applied for a grant after I'd been there a couple of years and got it funded. And I had that grant continuously renewed for about 28 years. So I was one of the very few people that was studying the chemistry of psychedelics over that period of time. Because of my postdoc in pharmacology, I also did smooth muscle and behavioral assays in mice and cats, in addition to synthetic chemistry. Later on, we got into receptor modeling and receptor mutagenesis and got into the molecular biology, trying to identify what were the structural features of psychedelic molecules that made them active, that made them psychedelic. In 1993, I started co-founded the Hefter Research Institute. And nobody, of course, at that time had been doing clinical studies. All the clinical studies ended probably with the last one at Johns Hopkins in 1976, but nobody was getting funding. And if you're an academic, there's no future in doing research that you can't get funded. So I would go to scientific meetings, and there were people there that had, like me, had been raised in the 60s and had been kind of interested in psychedelics. And we'd bemoan the fact that there were no clinical studies. And that was really, I mean, I was doing rat studies and mouse studies, but that doesn't really tell you much. And so we'd talk about that, and then I'd go home from the meeting and life would just go on. And at a certain point, probably in 1992, I went home from a meeting, and I remember sitting at home thinking, you know, you're going to be 80 years old, sitting in a rocking chair telling the same story, and nothing will have been done. So I decided to start the Hefter Research Institute to try to raise money from philanthropists to get this field, get clinical stuff going again. So that was in 1993. We were incorporated in New Mexico. I recruited some other people in the field, Mark Geyer and Charlie Grove, George Greer, and we started this organization thinking that we get lots of money from philanthropists. We generally thought the people in the tech sector in California, the Silicon Valley giants that had lots of money, and many of them had confessed to using LSD. We thought, well, they're going to give us money, but they actually didn't. I remember one donor, it was a real estate developer in the early days of Hefter, who gave us $10,000. He gave us a check for $10,000 and said, and kind of whispered kind of quietly, no one can ever know where this money came from. You know that, right? So that's how bad things were back then. Nobody wanted to be affiliated with this research. But we did get some work done. We funded part of a study using psilocybin in obsessive compulsive disorder at the University of Arizona. Then we funded a Charlie Grobe study of psilocybin use in end-of-life patients. And then, of course, we supported and funded the studies at Johns Hopkins and at New York University for cancer in end-of-life patients. And in the meantime, also, I had met Rick Doblin at a meeting at Esalen in 1985, and as well as Rick Strassman. And Rick, his PhD thesis, you may know, was how to make MDMA into a drug. And he was still a student at New College, but he had become devoted to the idea of making MDMA into a drug. And so, and he talked about that some. I thought it was a very unrealistic expectation, but still, when he came to me and said, before I can do this, I need MDMA for preclinical toxicology studies. Could you make some? Because nobody else would make it for him. So I agreed to do that. He paid us $4,000 for roughly 1.5 kilos of high purity MDMA. And that's the MDMA he used for all of MAP's phase 1 and phase 2 studies. And then a few years after that, Rick Strassman, who I encouraged to do a clinical study, he was a psychiatry professor at the University of New Mexico. And he and I had a long correspondence, as well as some meetings with Danny Friedman, who was the interim head at psychiatry at UCLA. And he said, you know, okay, so it looks like I could write this protocol up for using DMT, which is what he was interested in. But what if I get all the protocols approved and everything's going great, and nobody will make the DMT for me? And I said, well, I just made a bunch of MDMA for Rick Doblin, and DMT is easier to make than that. I'm sure I could do that. So that's exactly what happened. When he got all the protocols and everything was approved, he said, but I can't find anybody to make DMT that's suitable for administration to humans. So I made the DMT for him. And then he wanted to look at psilocybin, but the synthesis that Albert Hoffman had used to make psilocybin involved a reagent that would spontaneously detonate when it was pure. My technician came to me and said, you know, I really don't want to do that. I don't want to use that reagent. And I agreed with him. So we spent some time finding a different way to make psilocybin. We made about 4 grams using a procedure that's not used now, but which worked for us, and made 4 grams. And that's what Roland used for his first study in 2006, where he gave psilocybin to normal volunteers. And that was the first point where he said that a high percentage of them said that that was one of the most meaningful experiences of their life, most spiritually meaningful. And so then he came back some years later and wanted a larger batch because they wanted to do the end of life study. So we made 20 grams of Roland for that. So we really kind of enabled some of these studies where there was no contractor that would make Schedule 1 controlled substances. Even today, it's difficult finding contractors who want to work with controlled substances. So we kind of got that going. In the meantime, I trained 45 or 50 graduate students and postdoctoral fellows. I had a grant to study MDMA, published the first work on the mechanism of action of MDMA as a serotonin releasing agent. Basically published 350 or so publications, papers, book chapters, and was funded and was sort of the person, if you're a graduate student at some other school, Vanderbilt University Medical Center, for example, invited me down to give a seminar about psychedelics. No one was really in the field, so I was out there talking about this, and basically there just wasn't any funding. Lots of people were interested, but there just wasn't much funding for it. So I just basically continued on doing my work. When we started the Hefter Institute, we debated what to call our mission. Was it going to be to study hallucinogens, or was it going to be psychedelics? And several of us advocated for psychedelics because it meant mind manifesting, which was a much better definition than hallucinogen. And we were counseled by some pretty big players, don't talk about psychedelics, they're going to think you're a bunch of hippies, etc. But we disregarded that. And now you see most everybody is calling them psychedelics. And of course, we decided to use psilocybin in the trials that we supported. And I can go into the rationale for that, but it was because it was generally recognized to be safe, it was short acting, and we could do clinical trials in a day, whereas if we do something like LSD, it would take all day and you'd have to keep people overnight. It would add to the cost of the trials. And so now you see psilocybin has become widely adopted as sort of the drug that most people are using. So the Hefter Institute we really promoted the use of the term psychedelics outside of the hippie community, and really promoted the use of psilocybin. And that seems to have kind of taken hold. So I retired from Purdue in 2012. Brian Roth offered me an indefinite sabbatical in his lab just to come and play. He said, whatever I want, just have fun. So I've been here since then. Did some research when I came down, have provided some compounds that were not controlled substances, have reviewed some of the work they've done. Brian has a big lab though. He has 25 people in his lab, just got a big $25 million DARPA grant. So basically I've been kind of a groupie, hanging out and watching what they're doing and making comments whenever I can. So I've kind of kept my finger in the field a bit. I've written a couple. I wrote a review recently on the history of psychedelics and psychiatry that came out last year. In Frontiers of Psychiatry, I just wrote a short review of how we came up with the name Entactogen for MDMA and MDMA-like compounds. So I feel like I'm not very self-aggrandizing, unfortunately, but I feel like I've had a bit of a hand in getting this field going, promoting the field, making substances for people, and writing important information and training 45 or 50 graduate students and postdocs who wanted to work in this field. So that's it in a nutshell.
That's great. And here right now is UNC, right? You just mentioned that.
Yeah, I'm an adjunct professor here.
Great. So I want to get back, and I think we will in the other questions, to all the historical perspective you have on the field. But just to sort of lay the groundwork, I think most folks watching will know, but not all will. What defines a molecule as psychedelic?
If you go back to Goodman and Gilman's pharmacological basis of therapeutics, the definition I like is they are substances that produce changes in thought and affect which are not or cannot be experienced otherwise except in times of dreaming or during religious exaltation. And I like that definition. They don't typically produce hallucinations, so they're not hallucinogens. I really think they are mind manifesting, which was Humphrey Osmond's original term.
Got it. And there'll be some folks who are pretty sophisticated about the chemistry here, but that won't be everyone. I suspect some of the people watching will have, heard of sort of various charismatic drugs, like there's magic mushrooms and LSD and ayahuasca, peyote or whatever, but they may not have a sense of the different groups of psychedelic molecules. So can you give us kind of a taxonomy of the classes of compounds, say tryptamines and such, and which I don't want to call them street drugs, but which well popularized drugs fall into those categories?
Right. So there are essentially three separate classes. There are the phenethylamines. Mescaline would be the prototype. That was isolated from the peyote cactus by Arthur Hefter in 1896. 1897 was published. He got samples from Park Davis of peyote cactus and it was able to extract individual alkaloids out of the cactus and took what was a dose of the cactus and took the alkaloids from a single dose of cactus and took each one himself and identified mescaline as the active principle. Arthur Hefter, a lot of people don't know about him. He was an incredibly important person. He had a PhD in chemistry, a PhD in pharmacology, and an MD. He was the guy who invented the hair test for arsenic. Arsenic was used widely in the 19th century for poisoning. People didn't want a little baby, they'd get some arsenic down at the store and just put it in their baby's food, or if they didn't like their boss or whatever. Arsenic, there's a whole book written about the arsenic generation. So he developed a hair test for arsenic. He was a public health expert. At that time, they put lead liners in the caps of beer bottles. He said, you got to take those out. They're leaching lead into the beer. Any question of public health, he was the guy, the go-to guy. He was the head of medical school in Germany, Berlin, and he also went to Switzerland for a while. So the phenethylamines, because they're easy to synthesize, were the things that I worked on as a graduate student, and Sasha Shulgin primarily worked on. They're fairly simple to make, and they're easy to modify and make derivatives. So there's a whole class of those, some of which are better known than others. STP or DOM was probably one of the first ones. 2CB is a phenethylamine that was widely used by recreational folks. So there's the phenethylamines, easy to make. The second category would be tryptamines. Tryptamines, actually dimethyltryptamine or DMT is produced in minute amounts in human body and in many mammalian organisms and many plants. It's a very short-acting molecule that's not active orally, but is only active after smoking or nasal insufflation. Lasts 15, 20, 30 minutes maybe at the most. Psilocybin is actually a tryptamine as well. It's a 4-hydroxy DMT, except it has a phosphate group attached to that hydroxy. And if you take psilocybin, it's produced by psilocybe mushrooms, a variety. There are 200 species of psilocybe mushrooms. If you take psilocybin or one of the mushrooms, in the GI tract, the phosphate group is clipped off. And what's actually produced is a compound called psilocin, which is 4-hydroxy DMT. It is orally active, and I've published on the reasons why it's probably orally active. Doses from 15 to maybe 30 milligrams, last 4 to 6 hours. And it has effects like the classical psychedelics, like mescaline. Mescaline is orally active. It's in the peyote cactus, but it lasts 8 to 10 hours. So 4 to 6 hours for psilocybin. 5-methoxy DMT also occurs in nature. Commonly, it's found now in the Sonoran desert toad, and people will milk the parotid glands, and there's an exudate there, which is toxic. So if a dog bites one of these toads, it squirts this into their mouth, and it's quite toxic. But if you squirt it out onto a little piece of glass plate or mirror, it dries up and scrape it off. So it's got 5-methoxy DMT in there, but it's also got a bunch of toxic substances. But when they smoke that, the toxic substances have high molecular weight and they just pyrolyze, they break down. And so the 5-methoxy DMT. So if you hear people talking about 5-methoxy DMT, it's almost synonymous with the toad, what they'll call toad. That's also a tryptamine. Those are the most common ones. There are some things like DIPT, diisopropyltryptamine, was discovered by Sasha Shulgin, and that one produces a change in your auditory perception. So those are the principal ones: DMT, psilocybin, and 5-methoxy DMT. And then the third category, they're specialized examples of tryptamines, are the ergolines, which includes LSD. Ergoline is a 4-membered fused ring structure that's fairly flat. These were originally isolated from the ergot fungus. Ergot infests rye products, grain products like rye, and was known throughout the Middle Ages. In fact, in the Middle Ages, there were about 40,000 people that died of ergot poisoning. So if you had a damp, cool year where the grain became contaminated with ergot, they would just thresh all this grain together, and it would have these ergot, they're heads of grain that are black. They're sclerotia, they're the dormant form of the ergot, a fungus, and it contains ergot alkaloids. Some of them are very toxic, ergotamine, for example, and they produce vasoconstriction, a constriction of blood vessels in the fingers and toes. So people during the Middle Ages that ate ergot-infested grain would suffer this intense burning and necrosis of their fingers and toes. So they would feel this burning sensation because the fingers and toes actually look like they're black because of the vasoconstriction and the necrosis. And the St. Anthony, it was called St. Anthony's fire. St. Anthony is the patron saint of people that develop ergotism. So Albert Hoffman, when he went to work for Sandoz, Albert Hoffman, I should mention, was an extremely talented natural products chemist. His PhD project was to ascertain the structure of chitin, which is the exoskeleton of things like lobsters and insects, this hard material. And he did that structural elucidation in about 3 months. And he went to his major professor and said, okay, what do I do now? And he said, nothing, you've just solved this problem. That's the whole point of a PhD. And he recommended Albert to Sandoz Laboratories, which is in natural products. So Albert went to work at Sandoz and for a long time worked on some cardiac glycosides, a plant called squill. But then he was intrigued by ergot alkaloids. And he went to Professor Stoll, the director of natural products there, and said, I want to work on ergot derivatives. And Stoll was kind of skeptical and said, you know, these are really tricky molecules. They're expensive. We can't give you much. But he persisted. So Stoll let him work on ergot. And he made a number of ergot derivatives, some of which are still used. Prevent postpartum hemorrhage in childbirth as a major use. Preventing migraine was another one. But anyway, he made a series of these, and I don't know how many he made, maybe 70 or 80 of them. And the 25th in the series that he made in 1938 was called LSD 25. Lyserge Sora is the German for lysergic acid, and diethylamide was LSD. So that was the acronym. And he made it in 1938, sent it down to the pharmacology people. And they said, you know, this isn't really very interesting. They put it in mice and whatever other assays they were using. Didn't think it was very interesting and sent back and said, you know, nothing to that one. And then 5 years later, in 1943, he was eating lunch. And he just had this sudden intuition that they had missed something with this compound, that LSD 25 that he sent down had some properties that somehow they'd missed it. So he decided he would synthesize another sample and send to him. Now, in a drug company, if you make a substance and send it to pharmacology and they say it's not interesting, it would be very rare, especially in a German society, Swiss German society, to make another sample and go down and tell them, you know, I think you missed something. You need to test this again. So fortunately, he didn't have to do that because he became intoxicated on Friday afternoon of the 16th of April, 1943, rode home and saw these kaleidoscopic visions, and he thought, wow, you know, something happened. What happened to me? Something in the lab I must have been working with. And he finally decided it must have been this LSD 25 he prepared a new sample of. And he thought that must be what it is. So he came back in on Monday the 19th in 1943, April, and weighed out a solution that contained 250 micrograms of LSD and drank it. And of course, at that time, he thought nothing of it because there wasn't anything that was as potent as producing an effect at 1/4 of a milligram. Even today, LSD is really much more potent than almost anything else. And that turned into his ride home on a bicycle. They were doing gasoline rationing during World War II, and so he rode his bicycle home. His lab assistant pedaled home after him. And Albert said he thought he was going pretty slow, but his assistant said, no, you were going at a good pace. Went home and laid down and had all these powerful, colorful visions and sent for the doctor. His wife was out of town visiting relatives. Sent for the doctor. And then the doctor came and said, well, did his vitals. Looks like your heart's okay, your blood pressure's okay. Just lay here and take it easy. And that was the first trip. And that trip has been more memorialized in some circles as being bicycle day. So every April 19th, people will talk about it being bicycle day because that's the day Albert Hoffman rode his bicycle home from Basel. So the ergolines are difficult. The total synthesis of lysergic acid was accomplished, I believe, in 1956 by Ed Kornfeld, who was working at Eli Lilly then. And Robert Woodward, who was a really outstanding natural products chemist, was a consultant to Lilly. And a lot of people have attributed that synthesis to Robert Woodward. But Ed Kornfeld, who I knew at Lilly, was the one who had actually done the total synthesis. But you couldn't make ergot derivatives by total synthesis, just not practical. And a total synthesis of lysergic acid has been kind of a Mount Everest for natural products chemists for years, come up with a new synthesis and you can publish it. There are a few that are maybe tractable. You might be able to make small amounts of them, but there's nothing that's really scalable that's been come up with where you could, have a reactor and make, 10 kilos or whatever. Mostly it's been obtained by submerged fermentation, Claviceps paspali, and a submerged fermentation. They grow ergodoctyloids and harvest them that way rather than harvest them off the plant grains. We did a little work with lysergic acid derivatives. We made probably 15 or 20 derivatives where we replaced the diethyl group, because LSD has a diethyl group, trying to understand why the diethyl was unique, because almost any change you produce at that position drops the potency of the molecule by about tenfold. We did some work to understand why that was, made some analogs of the diethyl groups, and actually there is a place in the serotonin 2A receptor that accommodates that, but there's a loop in the receptor that folds over LSD, and LSD has difficulty getting out of the receptor because there's a leucine, it's a big amino acid that kind of locks LSD in there. So we did some of the work to explore that. Also made some analogs. LSD has an N-methyl group. We made a whole series of LSD analogs where we replaced that methyl with an ethyl, with an allele, with a propyl. Some of those, the ethyl is actually more potent than LSD. Some of those have shown up as recreational chemicals. FLAD, ALAD, LSZ was one we made that had a 4-membered azetidine on it. So those are the 4 classes. Phenethylamines related originally to mescaline, tryptamines related to DMT or psilocybin, and then ergolines, LSD principally, where you can modify the amide substituent, but you don't get very far with that.
That was great. Thank you. I think the next logical follow-up is to just get a sort of high-level lay of the land of the current pharmaceutical development of psychedelics. So what, pairings of compounds and indications are sort of in the lead, or at least farthest along?
So of course, psilocybin has been the most attractive so far because we know from those early studies, the 2016 studies from Johns Hopkins and New York University in end-of-life patients, that psilocybin was very effective. When Charlie Grob started his study, we knew that LSD had been used in the 60s at the Spring Grove Hospital with Stan Groff, had been used to treat end-of-life cancer patients. But we didn't want to use LSD because we thought that would create a media feeding frenzy. Remember, this is in the 1990s. So we thought, what can we use? And plus LSD was long acting. So we went through mescaline's long acting. We thought that would make people sick. A lot of people get sick and vomit when they take mescaline. So you didn't want to take dying people and make them sicker. So let's try psilocybin. It's short acting. It's been used in South America. People ate the mushrooms. Millions of people have probably taken psilocybin mushrooms. So that was what we started with. And I think, and that led in, and of course, Roland Griffiths did his 2006 study of psilocybin in normals, and then the 2016 study. So we had kind of a base of clinical studies where people had used psilocybin with promising results. I think what's happened now, and of course, Compass has been the big 800-pound gorilla in terms of moving psilocybin therapy forward. I think when people have either looked at psilocybin or they've tried to look at shorter acting things. One of the issues about assuming these have therapeutic utility is how do you scale this up so that people can afford the treatment? So for the studies we did at New York University, and now these are of course experimental academic studies, but we estimated that each one of those patients cost about $25,000. Now, if you translate that to the everyday guy who comes in off the street who's depressed, you're not going to get any insurance company to pay you $25,000. You might be able to get it to $8,000 or $10,000. They're probably still not going to pay that. So one of the issues is how can you scale it up? So you could go with something that's shorter acting, and as you know, that's what Eleusis is trying to do with a salt of psilocin and IV infusion, thinking that we can limit the duration to maybe 2 hours, or short acting compounds. We know that DMT is being exploited by a couple of companies because it's short acting. And 5-methoxy-DMT also is being looked at as a potential. The other thing that's out there is ayahuasca, and I didn't mention that before. Ayahuasca is really an orally active form of DMT. So there are people that have looked at ayahuasca, but not in the US because it's an admixture of extracts from two plants. We never really thought the FDA was going to look at that very favorably because of standardization and admixtures and things like that. But that's also a case where it looks like there is evidence for therapeutic efficacy against depression for ayahuasca. And so that presumably is mostly an orally active DMT. There is a company now, Numinous, I think is the name, that's trying to grow standardized psilocybin mushrooms, freeze dry them and powder them and put them in capsules, because there are people out there that don't trust big pharma, right? So if it's synthetic psilocybin made in a flask, they don't trust it as much as if they could get a powdered mushroom that nature made. And I don't, I'm not susceptible to those kinds of arguments. Some people are.
Medicinal chemist, that's not persuasive to you?
No.
Yeah, and then just a couple other points to make sure we touch on them. So obviously there are folks working on MDMA. And then the one other question is, and it was interesting to hear your definition of psychedelics, because I figured you'd just say, targets the 5-HT2A receptor, which would exclude ketamine. But I think yours may be broad enough to capture ketamine. So I know folks are working on that. So maybe you can speak on that for a second, or at least why ketamine could be interesting to the psychedelic space, even if it's excluded from many definitions of psychedelics.
Yeah, I generally talk about the classic serotonergic psychedelics, which would be the phenethylamines, tryptamines, and ergolines. Certainly, there are people that consider ketamine to be a psychedelic. And the definition of mind manifesting, I suppose you could say things happen with ketamine that you normally wouldn't have happened unless you were dreaming, or maybe having a religious experience. I don't know whether that would really fit in there or not. It works in a different mechanism. It acts at glutamate channels. It causes an increase in brain glutamate. The classic psychedelics do that, but through a different mechanism. They activate serotonin 2A receptors on deep cells in the cortex, and those cells, their transmitter that they release is glutamate. So you see increased glutamate in the brains of animal models, at least, who are given the classic psychedelics. So there is a connection. The difference is that whereas ketamine works for a week or 2 weeks, and you have to go and maybe have 6 or 8 treatments before you finally quit. Whereas with this classic psychedelics, at least with psilocybin, we've seen therapeutic effects that have a duration out to 12 months. And I haven't seen any studies that are longer, but even at 12 months, there was no deterioration in their, antidepressant efficacy. So they both may have a component of glutamate involved in there, and you can argue about glutamate mechanisms. But clearly, there's something different about the classic psychedelics from ketamine. The reason ketamine has gotten so popular is psychedelics are Schedule I controlled substances, and ketamine is an anesthetic. I don't know what schedule it's in, but it's typically available. Schedule III, typically available for doctors to use. So doctors have been, the ones that are interested in treating depression, have been using that. It works very well acutely. I think this effect was discovered around the turn of the century, around 2000. Found that severely depressed patients given an injection of ketamine had a rapid recovery from their depression. So that was the thing that really got people interested, because psychiatry is one of the most conservative branches of medicine. They haven't had new drugs really for a long time. So in psychiatry, you get something that can immediately alleviate suicidal depression. That turns out to be really important. My personal hope is that will be superseded by longer acting standard psychedelics like psilocybin.
How much do we know about the actual, well, let's limit it to psychiatric applications to start. How much do we know about the sort of actual therapeutic mechanism for psychedelics? Do we know why they might be efficacious for depression, or what's our sort of best sense?
No, I hope this phone doesn't ring again. Spam risk. Mr. Risk calls me all the time. Spam risk. I should have taken the phone out of here before I got on here. I forgot about it.
No worries at all.
Really, we don't know. There are theories that it stimulates the growth of new dendrites and synapses in animal models. If you give them psilocybin or LSD, what you can do is look in hippocampus and see that there's a dendritogenesis, synaptogenesis, formation of new synapses. In people that are depressed, if they look at the hippocampus in postmortem, they have a pruning back of the dendrites in the hippocampus. So they've made the connection, well, maybe you have to stimulate new synaptic growth, new neuronal growth, but that's not proven by any means. There is a company started by David Olson at UC Davis called Delix, and they're strictly going with mouse models looking at the stimulation of synaptogenesis and dendritogenesis, assuming that will translate into clinical efficacy. But we really don't know whether that's going to pan out or not, but that's one thing. How any of these others would work, I mean, in depression, you know, when you think about the range of things that classic psychedelics can treat, one of the earliest studies I can remember reading when I was still a graduate student was a paper. It was a 10-year follow-up published by a couple of co-authors, Brandrup and Vanguard. Took a person with severe OCD. This person was basically incapacitated by the extent of his OCD. He'd hear a toilet flush and he would have to wash his hands 20 times. He'd use 2 or 3 rolls of toilet paper a day. Extreme fear of contamination. Couldn't stop. And for some reason, he was taken into a psychiatrist and they gave him a dose of LSD and just left him in there for some hours with just a nurse to sit there if he needed to talk to somebody. He was given LSD, I think, once a month for about a year. And this report by Brandrup and Vanguard was a 10-year follow-up saying that at the end of this course of therapy, his obsessive compulsive neurosis was completely gone. People who knew him said his personality was better than it had ever been before. He went back to the job, he quit, was promoted to regional manager and became once a month, completely treated OCD, which is something you can't treat really very effectively. When we started Hefter, my idea was to start to look at eating disorders and anorexia, because I had thought that at least cognitively, you might be able to look at a woman who had taken this, and it's one of the most lethal psychiatric illnesses, that a woman who was anorexic could take psilocybin and look at herself in the mirror and see the visible manifestation of what her anorexia was doing to her body. And we talked about that, but we couldn't get anybody interested in doing a clinical trial. There is a clinical trial now. There are 2 of them, at least, one at Johns Hopkins, and I forget who's doing the other one, looking at anorexia and psilocybin. Yale University, Ben Kelmendi is doing a study of OCD and obsessive compulsive disorder. Michael Bogenschutz has done an expanded study of psilocybin and alcohol use disorder. He's treated 96 patients. I understand he's done the data analysis and the paper's been submitted for publication. We know about Matt Johnson's study of tobacco smoking and the ability to disrupt that. That was very effective, and he's now doing a much larger study with brain scanning before and after. So when you think about, and also end-of-life existential distress, how is it possible you can treat existential depression and distress, major depressive disorder, treatment-resistant depression, alcohol use disorder, tobacco addiction, OCD? If all these pan out, how is it possible for that a single drug to do that? Because we think of pharmacotherapy, you know, oh, you're anxious, we're going to give you a benzodiazepine or whatever, your blood pressure's high, we're going to give you a beta blocker. This is a completely different paradigm, and I've written about this. There's something different. And Robin Card-Harris, who's done a lot of work in the UK, he's at UC now in San Francisco. He gave a seminar that I sat in Copenhagen. And when he finished, somebody said, but how does it work? And he had this slide ready, and he brought it up, and it was a big red button that said reset on it. He said, it resets something. So there's some functional reset that occurs. And that's really what people are looking at now. A lot of the brain imaging work is being focused on what's actually happening before and after. What is this reset mechanism? Can we quantify it? Can we see what's actually happening? But that's the big challenge. National Institute of Mental Health hasn't funded any of these studies, but they say we will fund mechanistic studies. So somebody's doing a mechanistic study to look at why it does it. NIMH may be funding some of those. So far, they haven't really put much money. I think they funded, the first funding was from NIDA for a big multi-site study of tobacco addiction, I believe, following up on Matt Johnson's. Oh yeah, and Peter Hendricks at University of Alabama, Birmingham, is looking at psilocybin treatment for cocaine addiction. So it's, if there is a magic bullet, this is probably as close to it as anybody's ever seen. If all these small trials can be verified in phase 3 clinical trials.
Yeah, and this question is maybe related, or at least is related to the fact that it's difficult to identify the mechanism. So if you just look at the popular press for wellness trends, or if you happen to be a lawyer who lives in Venice and 35 years old, you hear a lot about microdosing psychedelics. But on the other hand, there doesn't seem to be a great deal of pharmaceutical development of microdosing. Are we looking at macrodoses because that seems to be what works on the reset button? What is the evidence on microdosing? I can certainly think of reasons pharmaceutical companies might be skeptical of microdosing as a successful product they could bring through.
But there have been at least one study of microdosing where it was found not to be any different from placebo. And my own opinion is, for most of these microdosing studies, first of all, a lot of them have been surveys where people have said, oh yeah, I take a gram of mushrooms every day and I just feel so much better. And then there was this book by this woman who said, my best day ever, microdosing. I'm not sure that really works. The problem is most of these microdosing studies have been done in normal people who wanted to try and see if they could boost their creativity or whatever. If it does work, it might be the case that it only works in people who have some kind of a deficit or illness to begin with. For example, the woman who wrote the book, I think My Best Day Ever, she was severely depressed, and this pulled her out of it. And it was with LSD. Now, the thing we know about LSD is because of the structure of the receptor, it takes LSD, it's difficult for LSD to get into the 5-HT2A receptor. And once it gets in, it's very difficult for it to get out. There's a leucine residue. There's a piece of the receptor that crosses over the binding site. And there's a leucine that pokes down in there, and it sort of wedges LSD into the binding site. And that's probably why LSD is as potent as it is and why it lasts so long. So it's possible that by taking these microdoses, you could accumulate enough in the receptor to maybe do something, but maybe not in a healthy person, but maybe in someone who's got depression or some other disorder, it might work. But we haven't seen any clinical trials like that. The trials that I've seen have been in well people. I think Elucis even did one of LSD base up to 20 micrograms, and you don't really see anything. So it sounds great. It's a really popular public meme, and people talk about microdosing as if it really works, but there's no clinical evidence that it really works.
Got it. And so we've talked mostly about psychiatric indications, addiction, and things like that. There are folks working on, including your son, of course, sort of anti-inflammatory properties of psychedelics on peripheral indications and things like that. I know that's all pretty nascent, but could you speak a little bit about why? I think folks on this call may not know that the 5-HT2A receptor is expressed throughout the body, so there's reason to expect it could, act on other parts of the body.
Yeah, so that's an interesting story. So when my son Chuck, who other people call him Charles, but he's my son, so I call him Chuck.
I'll call him Chuck on the webinar and say you authorize me.
When we named him, we thought, if he becomes a scientist, he can call himself Charles. If he becomes a baseball player, we can call him Chuck. So anyway, we call him Chuck. He was just starting at LSU when Katrina hit and wiped out all of he had frozen samples he brought in from his postdoc to get himself started, destroyed everything, destroyed his lab, destroyed everything down there. And when he went back after they started cleaning up, a lot of faculty had left, had departed from LSU. And there was a fellow who had been working in the Cardiovascular Research Center down there, who had a Chinese postdoc, Beng Mang, something like that was his name. And Chuck had been looking for a postdoc, but hadn't been successful. So this Chinese postdoc who'd been working in the Cardiovascular Center came and said, you know, I see you're looking for a postdoc. Could you use me? Well, he had no experience in CNS, but he had grown cells and so forth and so on, and had done a lot of cardiovascular work. So Chuck hired him as a postdoc. And he came in and he brought some cells. This is my understanding of the story anyway. He brought some of these, they were smooth muscle cells from cardiac tissue or aortic smooth muscle cells. And he said, we've been looking at these to block anti-inflammatory effects. They would put a substance called TNF alpha into the cells, and it initiates a whole cascade of inflammatory responses. And he said, have you got any drugs we could try? Because I've got these cells, they're almost to confluence, and you have to test them before they reach confluence. Well, Chuck said, no, I don't really have anything. Somehow Beng Ming knew about this. I had sent Chuck DOI because he said, are there any serotonin 2A agonist psychedelics that are not controlled? And I said, well, DOI is the only one I know of. And I had made DOI and I sent him a sample. So Chuck said, yeah, go ahead. It's a psychedelic, but you can, you know, if you're going to throw the cells away, you might as well test it. So the guy came in a week or so later and said, that's the most potent compound I've ever seen. It blocked all the effects of TNF alpha. And the EC50 was 20 picomolar, 20 times 10 to the 12th molar. Nothing is that potent. So Chuck was convinced he'd made a mistake mixing up the solution somehow. So Chuck made his own solution and reproduced the guy's data. So that was the first point at which they found out these things had incredible anti-inflammatory activity. Since then, he's gone back and looked at the ability to block an induction of asthma with egg albumin, to reverse asthma in a rat model, has looked at a bunch of anti-inflammatory effects. And it turns out that at least DOI is a very potent anti-inflammatory agent. And I'll tell you an anecdotal story. Andrew Wild was at a meeting. He was talking about psychedelics, and he said, you know, these things have some strange properties. He said, I was always allergic to cats. If I got around a cat and had a cat on me, I would break out with welts and things like that. And he said, I was tripping on LSD one day, and this cat jumped up on my lap. And I thought, oh no, I'm going to have a big problem. And he said he didn't break out in welts, never had allergies. And after that, he was never allergic to cats again. There are stories like that where there are responsible people and you say, well, I believe he was allergic to cats, but what happened? Something broke that cycle. So, you know, Chuck has been focusing on the anti-inflammatory effects, and we think they might be very potent in a lot of different inflammatory conditions. Well, that was an accidental finding that just really happened because he lost all of his research samples, and I happened to have the only unscheduled 5-HT2A agonist. So.
Yeah, so DOI is a good place to get into regulation a little bit here. And as I mentioned at the top, we'll have a lot of conversations where it's lawyers talking to lawyers. But you're a psychedelic research scientist. You've dealt with these regulations for a long time. Maybe you can talk a little bit about what having to have Schedule I licenses has been like, and why things like DOI are important for research. And then we can get into the DEA scheduling stuff a little bit.
Yeah. So I had... to do research with Schedule I substances, you have to have a Schedule I license from the DEA. And every substance you work with, you have to have listed. So I had 15 different substances. So if you want to work with a new one, you have to get your license amended to pick up the new one. So there's kind of a hassle. It's more of a hassle now than it was when I first started. The DEA is pretty, depending on where you live, can be very restrictive. In New York, when they started doing the study at New York University, they had like a gram of psilocybin, and they had to have someone take it out every day and weigh it in the presence of a witness to certify that none had disappeared overnight. So they're really stiff on these regulations. The dose of mescaline is, say, 250 milligrams minimally, say, If you want to do animal research with mescaline and you're only going to need 10 or 15 milligrams, you still have to have a Schedule 1 license. In the beginning, you just had to have it approved by the DEA. They wanted to see your CV and see what you plan to do, and then you had to do a calculation, how much you needed, how many animals you were going to use, and what dose each animal, and so you add it up and say, okay, I need 50 milligrams of mescaline or whatever. Then they changed the regulations, and now they send it to the FDA, and they ask them, is this research worth doing? And actually, in terms of getting the substances, they still, I and some other people from the corporation that sends the samples out for NIDA, Research Triangle Institute, I get these, I've gotten 2 or 3 of them now, where someone has sent in a protocol and said, you know, is this justified? Where somebody's proposing some experiments and the amount they're going to use, is this okay to give it, do you think? So they check that now, but the FDA also gets involved, like, is it worthwhile doing? You have to have a safe. I had a big locked file cabinet with a steel bar on mine that had 2 locks, plus I had a 2.5-inch solid oak door on my office, and then another outward office that had the same door. So you have to have a certain difficulty in getting into it. They had to buy an 800-pound safe in New York University. Chuck had to buy a big safe. So they're really trying to prevent any kind of diversion. You have to keep very careful records. And the problem is, if you're a pharmacologist or even a medicinal chemist and you want to do an experiment and you say, what if? I wonder if I did this, what would happen? If it's a chemical that's available that's not a controlled substance, you send in a purchase order to Tokris or somebody, and they send you a sample, you do the experiment. A lot of what if experiments are done that way. But if you want to do an experiment with a controlled substance, you can't do what if. I wonder what happens to hormonal levels if I give LSD, this particular hormone. You can't do that without a Schedule 1 license. So then you have to put everything aside and say, well, are you interested enough to follow the paperwork to get the license? You may be, but in most cases, if it's one of those what if kind of experiments, you're not. It's like, you know, it's going to be too much of a hassle to get a Schedule 1 license, and I'm not really that interested. Whereas if you could just get it and do the experiment, you might find out something interesting. So what's happened is the DEA has scheduled everything that is a known psychedelic. It's even worse in the UK. They've scheduled things that have never even been seen on the black market before, if they just resemble the structure of a known psychedelic with no history. In the US, at least, they, for the most part, not always so, not always recently, for the most part, they try to see that there's something they're seizing on the street that's a problem. They've had some adverse reaction or people are starting to use it. They control it all pretty closely. So if you want to get into this field, like my son, when he discovered the anti-inflammatory effects, if DOI had been a Schedule 1 substance, we never would have discovered the anti-inflammatory effects of psychedelics. So DOI is used a lot because you don't need a Schedule 1 license. A lot of experiments are being published. I think there were 800 papers published in the last 10 or 20 years using DOI as a tool to study the serotonin 2A receptor. It never became popular as a recreational drug because I think, in my opinion, it lasts too long. It lasts like 24 hours or longer. And for people that tend to not be very careful about dosing and take, oh, let's take a dose. It takes a long time to start acting. Oh, let's take another one, nothing happened. And then all of a sudden they're on a 36-hour ride, which they don't really enjoy. So I think it never got popular because it lasts too long, but it's the only tool that you can get that's not a controlled substance. But you still now have to have, I think, an institutional letterhead, an official purchase order to get it. You didn't used to have, but you do now, but it's not officially Schedule 1. So it's the only tool that people can get that's not a controlled substance if you want to study how these things are working.
Right. And I'll just drop a flag here for folks watching now or later, that there are lawyers who are resisting the DEA's current rulemakings to schedule some of these substances. There are comment periods. It's procedural rulemaking, and you can reach out to the Psychedelic Bar Association if you'd like to participate. We can put you in touch with who's doing that. So we're coming toward the end of our time here. This will be the last serious question. I'll obviously end with something comedic. So sort of blue sky, where do you see the field in 25 years or so? So at the moment, the emphasis is on, well, at this very moment, it's a lot of modifications of known compounds for psychiatric indications, right? Polymorphs of psilocybin for depression, things like that. But we talked a little bit about anti-inflammatory applications, and I suspect even 10 years from now, the main drugs being developed won't particularly be recognizable from just sort of the classical psychedelics. Where do you see it going? Will the main story here be this was an incredible cure for depression, or will there be some, whatever molecule that treats acute heart failure that we just don't know about yet? That's the biggest story from psychedelic development.
I think from what we know, asthma and inflammatory conditions may be useful. There's some evidence, for example, in animals that have had a transected spinal cord. If they put LSD in there with a nerve growth factor, you get some resprouting and refunction. So these things have potentials as anti-inflammatories, potentially for certain kinds of trauma, brain injury perhaps. They may be useful for that. The 5-HT2A receptor is the most widely expressed receptor in the body. I think depression right now is what people are focusing on. It's a huge unmet need.
Totally.
My stepdaughter, her mother. Yeah. Okay. I don't know. One expects that there might be new substances. What they're working with now are things that are known to work and are known to activate the serotonin 2A receptor. One would expect that probably as this field matures, there will be new molecules that are unlike anything that we've seen before that may have the ability to produce these effects. Whether or not there are going to be non-psychedelic psychedelics, as David Olson would say, nobody knows. I'm not sure that those are going to be good in every case anyway. A non-psychedelic psychedelic, so to speak, might be good for treating ordinary major depressive disorder. But when you listen to the videos of people that got it for end-of-life existential distress, there was a cognitive component there, this idea of having experience that you normally wouldn't have except during dreaming or times of religious exaltation. People who have been given psychedelics, psilocybin or LSD at end of life, have dramatic effects on their mood and outlook, which are not just related to a relief of normal depression. There's something else, I saw God and God told me, not to worry, that people are waiting for me, blah, blah. That kind of thing is not going to happen just with a pill. And that may be important for existential end-of-life distress. For people who have had substance use disorders, they often talk about focusing on when they started, why they kept using, focused on the pain they were causing people around them. These are cognitive effects that don't occur with just a pill you take. So I think, it may be that a pill will work for obsessive compulsive disorder. Although that case I mentioned, Brandrup and Vanguard, he said he had an experience where he started getting rapidly improving his health. And he said, I remembered the night that my symptoms started. I stepped off the bus and stepped in a pile of dog feces. And so that, was somehow linked to his fear of contamination. So these cognitive insights that you can get, I think, are important for some of these treatments. Maybe not for major depressive disorder, maybe not for obsessive compulsive disorder. I don't know about eating disorders, but I'm not sure that you can completely get rid of the psychedelic effects and have a therapeutic action. We'll have to see. And I can't predict which way that's going to go.
Great. So we're coming to the end of the time here. I'll end with a bonus human interest question. I'm actually kind of embarrassed I don't know this from working with you already, but so this will be new to me too. Do you have a favorite fictionalized depiction of psychedelics? Like a scene in a movie, something like that?
Matrix, maybe, I don't know.
All right, fair enough. Fair enough. Great. Well, thank you very much, David. This was great. And on behalf of California lawyers interested in psychedelics, we really appreciate you taking the time to answer some questions that are pretty basic compared to what you do with most of your day. But this was really helpful and really interesting.
It's my pleasure. Enjoy doing it.
All right, cool. Thank you, David. I'll talk to you soon.
Bye-bye.
Bye-bye.